introduction to sports psychology and biomechanics. Personality is what makes a person unique. Everyone has different traits and characteristics that make them different to everyone else, but people still share characteristics that will allow them to be divided into personality types. There are considered to be two personality types. These types are introverts and extroverts. Introverts are seen as quieter people who are happy to spend time alone rather than in big crowds. Introverted people tend to like sports that require concentration, precision, self-motivation, intricate skills, low arousal levels, individual performances. For example, an introverted person will enjoy a sport like golf because the performance is individually based, so they need to concentrate on how they perform as opposed to competing in team sports and relying on individuals they may not communicate well with. Extroverts are seen as louder and more outgoing and feel the need to be in the company of others as often as possible. Extroverts tend to prefer sports which are exciting, team sports, fast-paced, high arousal levels, large simple motor skills and low concentration. For example, football would be a sport for extroverts as they enjoy being in the team as it will add a social aspect to the sport. Extroverts also tend to enjoy more aggressive sports than introverts. Motivation is the drive behind how hard we work. In principle, low motivation would cause poor performance, as the individual would not try working very hard, whereas high motivation would make the individual work harder. Motivation is not as simple as that. To further break it down, we can see that motivation has two forms. They are intrinsic. Intrinsic motivation. This is your own desire to perform well and achieve your goals. Some of the main characteristics of someone who is intrinsically motivated include rehearsal and training of skills that they aim to improve, and feeling pride and enjoyment in performing the skill. Intrinsic motivation will come from enjoyment and passion towards the sport itself. For example, an individual who has always played football from a young age will be intrinsically motivated because they love the sport enough to consistently take part. They may play for a Sunday league for which there will be no prize money and very little recognition. Extrinsic motivation. This motivation comes from factors outside the athlete which can encourage the athlete to work harder. This falls into two categories: tangible rewards such as medals, trophies and money, and intangible rewards such as praise and recognition. Extrinsic motivation can be negative towards performance. An example is a professional footballer who is only playing for the money and has lost any enjoyment of the game. Extrinsic motivation can be effective when balanced with intrinsic motivation. For example, a football player enjoys playing football for free and may be further motivated by the choke. Hall's drive theory. Hall's drive theory demonstrates the relationship between performance and arousal. On the chart, at low levels of arousal, the athlete's performance is low. As the athlete's arousal increases, so does the performance. Hall's theory also explains that novices to the sport often do not perform well under pressure, whereas an experienced athlete will perform much better under pressure due to their superior skills. Inverted U theory. Inverted U theory explains that arousal will help to improve an athlete's performance to a certain point. When it goes past this point, the performance begins to decrease. An example is a football player in a tournament final may be too focused on winning the match, and then their performance will start to decline if they try too hard and become too aggressive. Stress and anxiety. Stress is feelings of pressure which can arise from being unhappy or fearful about a situation. When an athlete becomes stressed, this can affect their performance negatively, because feelings of stress may lead to anxiety, increased chance of injury and frustration, which will lead towards aggression. Catastrophe theory. This theory is based on the inverted U theory, but develops the theory to add in the effect of anxiety. When an athlete has low cognitive anxiety, they will perform better than when their anxiety increases. An example of this is during football, when a team is holding on to a one-goal lead and under heavy pressure from the opposition. Pressure to hold on to the win will increase anxiety, and the players will be more likely to make mistakes due to the increased pressure. Aggression and assertion. Aggression is also a factor in performance. While aggression can be negative if kept under control, some levels of aggression can help performance. There are two types of aggression: indirect aggression, which is taking aggression out on objects, and direct aggression in the direction of another player. There are different theories as to why we're aggressive. The natural instinct theory. This theory states that humans are predisposed to be aggressive to help us to survive. Frustration theory. In the frustration theory, a person who isn't able to achieve their goals becomes frustrated and aggressive. And the social learning theory. This is a theory that humans learn aggression from those around us. Assertion. Assertion in sport involves being forceful with your opponent or objects involved in the game, but without losing control and being too aggressive. It can be useful in some sports. For example, in football, when you want to have a powerful presence on the pitch without breaking the rules and being punished. Criteria for assertiveness. No intention to harm or injure. Does not break the rules and use of legitimate amount of force, and it should be goal-directed. Biomechanics. Biomechanics is the study of mechanics of the body. An understanding of biomechanics allows us to understand in detail the movement of the body. Biomechanics can be used to help us understand to improve in performing sport, but also to understand how injuries can be obtained. Application of forces. Force is one of the most important aspects of biomechanics. The definition of force is a push or a pull exerted by one object on another. Force has three variables: point of application, a magnitude, and a direction. Force is a push or a pull. Forces are acting on an individual at all times. An example of this is when lifting weights. As the individual pushes up with the weight, gravity will be the opposite force pushing down. Reaction forces. For every action there is an equal and opposite reaction. The ground reaction force is the force the ground creates towards a body or object on top of it. This is because forces always act in pairs. For example, when running, the athlete will push down on the ground with force to push off, and the ground will be pushing up towards the athlete. Momentum. Momentum is caused by force being applied, which makes the object move. It is difficult to change the direction of movement of an object with a lot of momentum. The more momentum an individual has, the less control they will have. Impulse. Impulse is used to increase momentum. The greater the impulsive force, the greater the change to momentum. Impulse has a direct relationship with momentum. We can use this to our advantage in sports where we want to try for the biggest amount of momentum. For example, throwing a javelin or hitting a tennis ball. For example, when throwing a shot put, if the athlete uses only the muscles in their arms, they will not be able to throw it very far. Whereas if they use the muscles in their arms, shoulders and chest, they'll be able to throw the object much further because of the increased force behind it. Newton's laws of motion. Newton's first law is inertia. This law states an object of constant velocity will remain in that state unless an unbalanced force is applied to it. So an object will stay moving in a straight line unless it is changed by an external force, as when an object stays still unless an external force moves it. For example, in hockey, the puck will continue to move across the ice until it encounters an external force. Acceleration. Newton's second law states force equals mass times acceleration. This can be used in sport. You can use it to calculate the force applied to an object. An example of this is in sport, is in basketball players. A lot of players will be able to move faster as their smaller mass will enable them to action and reaction. Newton's third law states that for every action there will be a reaction. Whenever two objects interact with each other, they create a force in each other. An example of this would be in baseball. When the baseball is hit up, it must come down. Projectile is a body or an object, for example a tennis ball. Any projectile thrown can be considered to have both vertical and horizontal velocity components. Factors that affect projectile speed. The faster the speed, the further the distance of the projectile. The optimum launch angle is 45 degrees, and the height at which the projectile is. While the projectile travels, change occurs in the vertical direction due to the influence of gravity, whereas the horizontal component of velocity will not change. The vertical velocity of projectile gets smaller on the upward path until it reaches as far as it will go. Then the vertical component changes direction and the magnitude increases in the downward direction. An example is a thrown tennis ball will follow a curved path, whereas the tennis ball that has been dropped will follow a vertical path. Lever systems. Levers are made up of the joints and bones that connect them to the objects being moved. There are three lever systems. They are first, second and first class. Levers are used to apply force. Longer levers will result in greater speed at the end of the lever arm, which will strike an object. First class lever system. In the first class lever system, the fulcrum is between the load and the force. In sport and exercise, the first class lever system is rare. An example of an exercise that uses this lever system is a dumbbell triceps extension. In this case, the fulcrum is the elbow joint and the force is applied while the second class lever system. The second class lever is also less common in the body. An example of a second class lever system is a calf raise. In a calf raise, the calf muscles pushing on the heel create the force, and the fulcrum is the balls of the feet, while the resistance. The majority of levers in the body are third class lever systems. An example of a third class lever system is a bicep curl. In this case, the fulcrum is the elbow joint. The force is the bicep muscle, and the resistance is the weight in the individual's hand.